Hello dear students, welcome back to Functional Studies 101. We continue with our presentation on the mock exam that was given to students of the University of Leipzig in Germany. So this is problem 3, and please, if you are new, kindly hit the subscribe button and don't forget to turn on the bell icon. It's very important. Please subscribe. Problem 3 is on limit, continuity, and differentiation. Okay, we have to prove that if f and g are continuous at x0, we have to prove that the minimum of f and g is also continuous at x0. So let's get into this. So by definition, when we talk of a function that the minimum of f and g is continuous, we want to prove it. We want to prove that this, since if it is continuous at x0, that's the minimum of this continuous at x0, then this limits as x tends to x0 of the minimum of f of x comma g of x will be the same as the minimum. That's it will be equal to the minimum of these function values at x0. That's from continuity of a function. Okay, remember the minimum is a function. When they talk about the minimum of f of x comma g of x, it means the lowest value between the two. If you have 2 here and 3 here, the minimum of 2 and 3 is the one that is smallest. That's the minimum. So when we are having f and g, they are continuous at x0. It means that the limit as x tends to x0 of f of x is equal to the function value, okay, at that point. Remember, when a limit exists, the left hand limit must be equal to the right hand limit, and that limit that you get, you can call L if you wish, it should be equal to the function value at that point. Since the function is continuous, okay, the limit as x tends to x0 of f of x is also equal to the function value at that point. Same goes for g of x. The limit as x tends to x0 of g of x is equal to the function value at that point. That's g of x0. From this point, we want to prove that the minimum of this will exist. That will depend on whether this man is greater than this man, or f of s is equal to g of s, or f of s is less than g of x. So we will now have two cases, one inclusive in the other. So these are the possible cases we are going to look at. The case 1, when f of x is what? Strictly greater than g of x. It means that the minimum of the two will be the smallest. If g of x is f of x is greater than g of x, means g of x is the smallest of the two. So the minimum of f of x and g of x will be what? G of x. I hope you understand that. So from here, it means that the limits as x tends to infinity, x0, of the minimum of f of x and g of x will be equal to the limit as x tends to x0 of what? G of x, because the minimum of this is g of x. And that will be equal to, since the function is continuous, g of x is continuous, right? They are continuous function at x0, so the limit will just be equal to the function value at that point. That's g of what? X0. That's the first case. The second case, so our case 2, the second case is 2 here. The second case is when f of s is less than g of x, or if they are equal, less than or equal to, it's inclusive the equality at once. I do not want to break it down again. So if it is happening like that, the minimum of f of s and g of x, if f of x is less than g of x, it means that the minimum will be what? Of the two will be f of x, the smallest one now. Yes. So in that case, our limit as x tends to x0 of the minimum of f of x, g of x will now be what? The limit as x tends to x0 of this minimum. The minimum is f of x. The limit of as x tends to x0 of f of x. Since f is continuous, this will just be equal to the function value at that point. That's f of x0. Okay. From this point, we have that the limit as x tends to x0 of the minimum of this will now be equals to this. We are proving that now it is true for all the possible cases, so we can generalize it. So finally, we have proven this. I think it's just rewriting the same thing. Okay, this one I forgot to cancel it, but it's the same thing. Just write one is okay, but we can conclude directly from here. Since we are proven that, then the minimum of f and g will be what? Continuous x0. We are proving this, that is true for all possible cases, right? So we can conclude that the minimum of f and g is continuous at x0. Hope you understand it. If you don't understand, you can inbox me on WhatsApp using my number. I forgot to indicate, but if you need, you can just use a comment section. I'll get to you. So this is the end of it. Hope you enjoy it, and thanks for watching. See you for more tutorials on this channel.